Hi, welcome to this presentation on Autodesk Kynapse. Kynapse is an artificial intelligence middleware solution for game development and real-time simulations. Kynapse gives in-game characters or entities three key capabilities: dynamic 3D pathfinding, 3D spatial awareness, and team coordination. Let's take a look at what Kynapse can do. In this demo, we have a user-controlled VIP and three bodyguards that protect it. I am controlling the VIP, so wherever I go in this level, they identify in real time the threatening positions in 3D. For example, if I move close to a wall, no bodyguard will face the wall because no threat can come from the wall. Instead, Kynapse helps the entity identify that a sniper can shoot from the windows or from access ways. Kynapse can analyze in real time the environment in 3D and identify key topological areas. We call this spatial reasoning. Note that there was no prior tagging of the environment to identify key topological areas. This is entirely achieved by the Kynapse toolset. The second capability that we illustrate is the ability for the bodyguards to navigate the terrain and move around the player while dynamically avoiding each other. This is 3D pathfinding. The third capability is the team coordination that happens between the bodyguards in order to cover the VIP. Notice that they do not all go to the same place, but split the coverage among them evenly. They share information and act as team members. So Kynapse is really about these three things: 3D pathfinding, spatial reasoning, and team coordination. Kynapse does not deal with the high-level decision making. We believe that this is up to the game developer, and we provide a toolset to achieve these decisions. This next demo again illustrates the three core capabilities of Kynapse. In this demo, we have a player character and numerous enemy AI which hide and shoot at me. Wherever I go, they will find me and shoot at me, but also take cover behind objects that block our line of sight. They have the ability to identify hiding positions through spatial reasoning. Once they have identified these, they have the ability to go there through 3D pathfinding. In order to maximize the threat to the player, they also coordinate amongst themselves and spread out their position. What is interesting is that if you were to go behind a column, you will see that they take cover behind that column. So they really have a complex understanding of the topology. Nothing has been manually tagged here. The hiding and shooting places are completely computed at runtime. It would be impossible to manually tag this terrain because we would have to anticipate all the possible positions where the player could go. So just to reiterate, Kynapse provides the tools to give characters spatial awareness, 3D pathfinding, and team coordination. A gameplay programmer will create his or her own logic and actions for the characters and use Kynapse to achieve the gameplay goals. In this next demo, we want to illustrate the Kynapse workflow. For Kynapse to operate, we need to generate a model of the terrain from an AI perspective. This is called path data and is generated by the Kynapse toolset very quickly. The Kynapse toolset actually creates two datasets, one describing the topology in terms of connectivity, and an AI mesh which describes the terrain in terms of borders and limits. The Kynapse data generation tool works by using a sphere collision function, which means that terrain can be anything from polygon mesh to procedural terrain. There really aren't any constraints on the type of geometry that you use. Data generation can be optimized through distributed computing. For large terrains, we can use a farm of computers to generate the data. This is highly relevant when we have large terrains for MMOs. What you'll also see is that if you modify data locally, for example, if we were to move a building, Kynapse is able to do a local recomputation, which saves a lot of time. So we've seen how the Kynapse data generation tool can automatically create path data. In this demo, we have a very large terrain, and it's actually impossible to load in all the data at once because it's too big. Instead, what we can do is stream in the local path data that we need at runtime. For this character, we have drawn a green circle, and within the circle we stream the data in so that it's immediately available. So what happens if we want to go from one side of a large map to the other? Because the map is too big to have all the data loaded at once, we use what's known as a hierarchical data structure with varying levels of detail. This is called hierarchical pathfinding, where we solve the path computation problem from a high level, then refine it as needed. This next demo illustrates dynamic avoidance and performance. Dynamic avoidance is a key AI algorithm. Here we have a crowd of 1,000 entities. We can create a traffic jam by selecting a few entities and sending them into each other, but entities will avoid each other. This demo also illustrates the performance of Kynapse, which is based on optimized data, optimized algorithms, and leveraging the power of hardware. For example, Kynapse can be run on a separate thread or run on an SPU. Now let's show some complex dynamic pathfinding. This demo illustrates complex topological navigation. As a character is finding its way from one side of a level to another, crates are thrown in its path and it automatically recomputes its navigational path. Note that it is not the crate itself which is blocking the character, but the aggregate of the crates. This allows for truly dynamic environments. In this final demo, we're going to show how Kynapse can handle dynamic edge creation. In this case here, I can add dynamic planks that will connect areas of the world that are normally not connected. And you can see how the entities can navigate and use these planks in order to reach their destination. This has been a short presentation on the key capabilities of Kynapse. If you have any questions or would like to arrange for an evaluation, we'd love to hear from you. Please contact us at middleware@autodesk.com.